All right, good morning, everybody. Hope you all enjoyed the keynote. There was a lot of talk about AI and where this world is going. So we're going to continue down that path, and we're going to talk about large language models, especially in running them on Kubernetes. So, as you know, my name is Fatos. I work as an engineering manager in the Google Kubernetes engine at Google Cloud Platform. I've been there for about 5 years, and in the last year or so, me and my team have been working very hard to actually bring open weights large language models close to the users. We want to give developers, like I'm guessing a lot of you are here, the opportunity to experiment fast, deploy large language models on Kubernetes, play around with it, experiment, and basically give you the opportunities to actually see how it looks like to run a large language model within your own infrastructure. So what we're going to cover today is we're going to cover a little bit what open weights models are, what inference servers are, what is Google Kubernetes Engine. Like, I would be remiss if I just didn't mention it at least once. And we're going to do a live demo. Actually, we're going to do 3 live demos. So if each of them has a 10% chances of failure, like, we might see something fail. I'm going to do a lot of questions like how many of you have heard, how many of you know. So please just raise your hand. It's going to give me an opportunity to also know how much to focus on certain things in these slides and provide you the best possible information. So starting with open weights models, how many of you know what open weights models are? All right, some people do. So there is a spectrum of AI model access. On the far left, we have the proprietary models that I guess everybody knows, the ChatGPTs of the world, Geminis, Claudes. They're closed source, closed weights. They're proprietary, and you pay per token usually, using an API key or something like that. Then in the middle is what we're going to be talking about, is the open weights models, like Gemma, Llama, GPT-OSS, Mixtral, which is one of our European ones, and DeepSeek, which I think 6 months ago broke the world. Since then, it tapered off a little bit, but when it was released, it was a big thing. I don't know if you remember. Everybody thought that NVIDIA is not going to be a very valuable company for about 2 weeks, and then everybody just got back into spending billions of dollars. So you can download these models, like you can run them yourself, and you can ensure data privacy, data residency. Like if you are a part of a very regulated industry like healthcare and finance, these are things that might be interesting for you. On the far right side of it is the open source models, which includes both weights and the data that it was used to actually create those weights, and it opens full transparency for research and the replication. In the middle, as I mentioned, we have the open weights models, which kind of provide you with the weights, but they don't provide you with the data set that was used to actually train those models. So an open weights models is the weight, as I mentioned, is a model where the weights are publicly accessible. You can download them. It ends up being one huge file, or several of them. We're talking about sometimes gigabytes, tens of gigabytes, hundreds of gigabytes of data. And you get an executable file, actually, to run, sort of. And this allows you or anybody in your company or anybody who wants to actually experiment with this kind of technology to actually get up and running real fast. After that, you can actually fine-tune the models, adjust them to your own use case. You can add new guardrails. You can provide access to deterministic data, and so on and so forth. So in a world where we have this spectrum of model access, why would you even use an open weights models? So if you're working in an environment where you want predictable cost and you are afraid of the vendor lock-in that you get with using a model as a service, this could be significantly cheaper for you. It's also a way to actually run the infrastructure, make sure that the data that is being processed is on your side, that you're not leaking any data. If you're dealing with customer data, if you're dealing, again, in a very regulated industry where you're doing with financial data or healthcare data, you wouldn't want to actually allow that data access to just anybody else. You can customize the models yourself. You can actually fine-tune them to your own purpose. So you can start with a general purpose open weights model and then adjust it for, I don't know, legal advice, for coding, or any kind of use case that you see fit. Who knows what inference servers are? All right, I have 2 or 3 people. Good. So LLM inference, for those that might not have heard in the last 2 years what it is the process of actually processing the prompt and generating the output of a given, for a given prompt. For any company that's dealing with building frontier models or actually implementing large language models into their business, the point of inference is you're going to hear your CEOs, CTOs, or maybe managers or something like that. They're going to start talking about it as the return of investment. So with frontier models, especially, training a model means losing money. Inference means making money. This is how it works. So if you had to put a parallel in between your standard software development, training a model would be everything you've done before you pushed your application to production, and inference is what happens when you actually push to prod. So the only time your users get value from a large language model is when the inference happens. Training is where researchers have their fun, they train their models, and they actually make the models capable about doing different stuff. But at the end of the day, the actual value comes from inference. There are several publicly available inference servers. Most popular recently has been VLLM. And I would be actually remiss not to mention that our teams at Google have been working recently, and just a week ago we released both the support for VLLM for TPUs, which wasn't the case before. So now if you want to run inference of your models, you can do that both with GPUs and TPUs. There are some other players in the market like TGI, which stands for the Hugging Face interface, if I'm not mistaken. So any models hosted on Hugging Face are going to actually use the TGI model inference server to serve. Triton is the NVIDIA inference server, battle tested, has been on the market for years, provides a lot of raw power. Each of these model servers has some benefit and some drawback. I'm not here to talk to which one you should use. It really depends on the use case, and it really depends on the model that you will be running. All right, I promise, 1 or 2 more of these and I'm done. How many of you know what Kubernetes is? All right. GKE, has anybody used Google Kubernetes Engine, or is everybody using EKS? All right. All right, so Kubernetes is the open source standard for containerization orchestration. So I think that everybody knows it's a scheduler of workloads, open sourced by Google 10, 12 years ago. Since then, took over the market when it comes to serving microservices. Currently being much adjusted to actually support the new workloads that are coming in the AML space. Google Kubernetes Engine is a managed service developed by Google, accessible through the Google Cloud Platform. And it does what your standard managed Kubernetes does. It takes care of certain things, so you don't have to. I'm not here to sell you on it. I'm just here to tell you that it exists. All right, so we're about 10 minutes in, so we're going to go into a live demo. And I know I spoke a lot of things about a lot of different things. So our demo today would be the VLM serving on Gemma 3. So we're going to be serving Gemma 3. So as I mentioned, there are multiple models that are available on the market. As I am a Google employee, I'm legally bound to use our own technologies. It would be the same as if I showed up on the stage with an Apple laptop or something like that. So I really need to use the Gemma in this demo. And we're going to be deploying it to the Google Kubernetes Autopilot cluster. All right. So 3 ways that we're going to achieve this. So there is the noob way, like the expert way, and like the full-blown laziness expert way, how you would do it usually if you actually had to do this in production. All right. So I'm in the Google Cloud console. This is the AML section. And what I'm greeted here is a list of potential models that I can deploy. So as you can see, we have the most popular families here on the top, which are Llama, Mistral, Gemma, and the rest. And I'm going to use the Gemma 3.1b just because it's the smallest model. It runs on a single GPU, so there's no problems with quota or anything like that. I don't spend a lot of company money running it, and we might actually see it deploy before the end of the demo. Again, we are talking about enormous files, like gigabytes and gigabytes of data that we want to actually deploy and load into the container, so it does take a little bit of time. All right, so starting off, we can do the first time. So if you are new to Google Kubernetes engine, or you're not an expert, you don't know how to use kube control, kubectl, whatever you call it, you don't feel comfortable in the CLI, probably Cloud Console is going to be where you land. So as you can see, like, I have an existing cluster that I'm going to call Autoplayer Cluster UI. I'm going to name my deployment to be Gemma test UI. I'm going to provide my Hugging Face token. I'm going to take care that like, I'm deploying to the default namespace. If you're doing this in production, don't deploy to default namespace. And I can actually take a look at my manifest here. So what I see here is like, I have a deployment. It has some labels, like your standard Kubernetes stuff. And then I have the containers that I'm going to be deploying. So I have the inference server containers, like running the VLLM inference server, and I'm requesting some resources. So I'm requesting 9 CPUs, and some memory, ephemeral storage, 1 NVIDIA GPU, and I'm going to mention somewhere that that's going to be an NVIDIA L4. So this whole model runs on a single NVIDIA L4 GPUs, very, very price affordable. So if you want to ever play around with it, it's very easy to get started. I'm also going to be deploying a service that's going to be exposing my application. And I just have to watch out. Yeah, so there is a secret here that I won't show you. So I will also be deploying a secret, which will hold my Hugging Face token. All right. So I'm going to click deploy. All right. So while that's happening, let's go here. All right. So we dealt with option number 1. So we actually started deploying one of the models. But what if like this whole ClickOps thing is not your deal? Like, you're a developer, right? Like, you don't click around. Like, CLI is where you actually like do your work. When other people look at your monitor, they think you're like Neo or something like that. So let's start that. All right. So I'm going to go in my DevDay demo folder, and here I have 2 files actually. The secret I already deployed to the cluster just for ease of use here, but I can show you my manifest here. So it's probably you don't see it. You know what? It would. So it's the same manifest more or less that I've shown you before. So like, you can imagine that you have this manifest stored somewhere. This is your declarative state of your deployment and your service. Like, as you can see here, we are providing the model ID, we are providing the Hugging Face token, and the reference. We are providing the startup script, which is going to be starting our VLLM server, and again, the same requests and limits that we spoke about earlier. Okay, so what I'm going to do is I'm going to do a kubectl apply -f All right, so let me dial down the zoom. So when you start deploying things on an autopilot cluster, I don't know how much you know about, but autopilot cluster doesn't have static nodes running in a Kubernetes cluster, so it's going to spin up dynamic nodes based upon the actual workloads that you want to deploy. So what we have here currently happening is those nodes are getting provisioned, and after that has been said and done, the workload will start deploying as well. All right, so these are two ways that we've deployed open weights models. But there is a third way, and I think that if you're actually managing any type of infrastructure in place, this is what you should be aiming at. So what I'm going to be using is I'm going to be using a config sync, which is a GitOps management tool, also created by Google. There are other tools on the market. The more popular one and the most popular one, if we're being honest, is Argo CD. And this is the tool of choice in a lot of cases to actually manage infrastructure in a GitOps kind of way. I'm going to go here. I'm going to say deploy cluster package. I'm going to choose my cluster. It says hosted on Git. I'm going to say Gemma test GitOps. So you can see that I tested this before. And I have, should have prepared this. So I have a repo here that I've actually checked in all of my YAML files, so all of my manifests. I have the deployment manifest, I have a namespace that we won't be using at this point, and I have the service manifest here. So very, very basic. It's a GitHub repo. This GitHub repo is also open to public, so if you want to actually go ahead and use it, it's Fatos Hoti / devdaydemo 2025. It's really, you can find this stuff online. There's many, many examples of deployment YAMLs cruising around the web. So you can use this one. You can use whatever you want. All right. So what I have here, I'm deploying a package. So I'm saying that my YAML files are located in this GitHub repo. I'm going to go to the head revision path. Branch is the main one. And I'm going to say deploy package. All right. So as we see, now this package started deploying. I won't bother you with what config sync does, but it kind of does git clone and kubectl apply. So you can sort of take it in that way. So it's going to clone your repo, and then when you make a change in the repository, it's going to trigger a workflow that is going to be applying those changes on your cluster. So very, very nice way to actually manage infrastructure, keep everything in place. GitOps is great. All right, getting back. So as you can see, we have 3 models here deploying, but I didn't want to risk us waiting, so I actually had one deployed before that. So what I'm going to do is I'm going to actually test this model. So I'm going to log in into my cluster. So I want to zoom in. So I'm going to get my credentials. Then I'm going to forward the service. So what this does is it actually allows me, I'm actually proxying the service from an internal IP to one accessible to me. And I'm going to shoot 100 requests at this endpoint. So the endpoint is completions. There's a few endpoints that the model server will give you. They're usually aligned across different model servers. So it doesn't matter what client you use, it's always going to work. I think that it was DeepSeek when it was released. They released a testing library where they used the actual OpenAI client JS library. And it just works. It's the same prototype. It's the same proto that's being sent around. So all works. All right. So, okay. So we can see that we sent 100 requests to our model. And what is the interesting bit around it is that we can now actually take a look at what this has done. for our model. So we have a few inference dashboards. So this data is a little bit late. Like it takes a little bit of time to actually load. So I'm going to show you some other metrics. So when you're running this kind of inference on your infrastructure, you have to take care of like the resource consumption and everything that goes with it. So what we've built in the last year is the actual built-in observability platform for inference models. The model performance will show you latency and like these kind of metrics. Infrastructure usage will show you your standard golden signals. Like, is anybody a DevOps engineer here by any chance? Cool. So like your standard golden signals, like compute, memory, network, storage, like all of that you can see. So you can see here that we had a spike of CPU utilization, like that sort of corresponds with the 100 requests that we sent. Same thing about GPUs. For TPUs, we don't have anything because we're not using them. Then we're going to take a look at memory. So more or less a flat line here. Nothing to say there. Network, network metrics are a little bit late usually. And storage, like this is also going to be a flat line because it basically is the memory requests that we are making inside this deployment. Next to your standard infrastructure metrics, you can actually check out the DCGM metrics, which stands for NVIDIA Data Center metrics, and you can actually get a little bit more information about like how your GPUs are behaving. So they're very far away. You don't have insight into them. You cannot go into the closet, into the rack, and actually check them out. They are somewhere in the US or in Europe chugging along. So actually getting an idea like in what state they are running is really, really good. All right, so as you can see, like, we have a ton of metrics here that we can provide you, like with the average GPU utilization, average GPU temperature, and like advanced utilization here. And finally, the I/O metrics. So by actually running your large language model, you get the whole complete overview of what's happening there. So next to observability, like you have the like out-of-the-box supported logging. So you can actually see here, these are our requests. Again, I'm going to zoom in a little bit so you can see better. So these are the requests that we were sending. So if you take a look at it, like we see what is the highest statue in the world, and like you can see actually like your application logs as well. So events. So there's going to be none, but maybe in the some other deployments. Very common way of debugging Kubernetes deployments. You have it for your resource here. And at the end of the day, if you want to check out your actual manifest and how it looks like as a YAML representation, you can check that here. You can copy it or download it if you want to check it then. So you can imagine this whole process being like you're starting with like deploying something to the UI, like you're downloading this YAML, you're checking it into your repo, and then you're productionizing it through a GitOps kind of service. All right, let me get back here, and then we can check if our models have deployed. All right, they're still running. I want to show you one more thing before we actually continue, and it's going to be connected to another model. There are teams at Google that have been working hard on actually benchmarking these models for very different purposes. We have a service in place that's called Google Inference Quick Starts that is going to provide you with different profiles in which you can actually run your model. So if we take a look at here, we have the Gemma 3 4 billion, so a model that we benchmarked recently. You can actually adjust the maximum latency that you're expecting from the model in place. And it's going to recommend which accelerator you can use to run it. So if I really pull this on the left and I want minimum latency, the GKE service is going to provide me with the information about my token throughput and latency expected, and the equivalent cost per million tokens. So you can actually plan your cost like going forward. So if I move this to the right, like I actually have an option here. Like I can run it on the older GPUs. So let's say that this is not live inference. This is some background inference that you are running for your company, some like analysis of a data set. So latency doesn't play that big of a role. Like minute here, minute there in a background process. Like who really cares sometimes? So to save money, you can actually choose a different accelerator type. But that's all said and done. What about the situation where you don't want to use the open weights that are hosted on Hugging Face? Like, let's say you downloaded, you fine-tuned your model, and now you want to redeploy it. So we give you that option as well. So if you store your weights in Google Cloud Storage, like there is a very, very simple way of how to actually go about. I don't have any buckets here, but you can imagine something appearing here, like a weights file. You can actually go and store the weights in Google Cloud Storage, which is, for people that know, is the same as S3. You can actually serve them from your own storage. So if you have proprietary weights that like, you use to fine-tune open weights models, or like you built a model from scratch, apparently you can build a ChatGPT-2 in an hour and a half. So like if you ever want to do that, that's also an option. So like, and you want to store this, and you want to actually serve it from your own weights, you can do that as well. And we provide you with just the deployment manifest to make that easier for you. We are aware that Kubernetes can be scary, that YAML doesn't always look pretty. So we provide you with the tools to actually get that fright away as much as possible and allow you as developers to actually do what you want to do with it, which is experiment, play around, or like implement something cool that you have an idea or a vision for. So, getting back, we said like we have 3 ways to deploy models. So we took a look at like the noob way, the kubectl way, and the config way. And we had 3 demos, and none of them failed, or all of them failed because they're still deploying. We don't know, but we're going to say that none of them failed. So I'm going to take that win, and thank you.
Thank you very much, Fatos. Now, please, can we put there the Slido slide, please? So we are using Slido here at the conference. You can ask your questions. So there is one for you, Fatos. It's very recent, very reactive to this week. So did the recent AWS outage have any impact on you, both personally and or as a Google employee?
Yes and no is the answer to that. No, because we don't run anything on AWS. And yes, all of a sudden, everybody got super afraid of multi-region outages. And there were 2 teams that were spun up to actually do an audit of all of our systems and to check if they are vulnerable to multi-region outages. So again, yeah, not directly, but I have a few tasks that I need to assign now to some of the engineers on my team related to multi-region outage playbooks and stuff like that.